the nature of substances and chemical reactions. This is a filled in review sheet for anyone who's maybe missed a certain part of the topic or just wants a recap in terms of revision. So the first thing that you're asked to do on the review sheet is define the following words. So element contains only one type of atom. Atom, the smallest unit of matter. Compound, two or more types of atoms chemically combined. Mixture, two or more elements or compounds not chemically joined and can be easily separated. Molecule, non-metal atoms joined together. These are the definitions you have to give in the exam. Moving on then to look at chemical formulae. So sometimes you'll just be asked to give an element. So these are just the ones that you find in the periodic table. You might be asked to define to give molecules. The molecules are all of group 7, oxygen, nitrogen and hydrogen. They're the only ones that exist as diatomic molecules like that. So all of group 7, nitrogen, hydrogen and oxygen. So they're the only ones that exist like that in a pair. And then compounds, stuff like water, H2O, methane, CH4, ammonia, NH3, and then hydrochloric acid, HCl. Okay, make sure you put in the little 2 as a subscript, so down below, or the little 3. They are not whole numbers, they're small numbers. And then when you're doing something like hydrochloric acid, so that's hydrogen and chlorine, as you can see, the L is a little l, not a capital L. If it was a capital L, it would be a different element. Okay, space filler diagram. So I've given you the key that I used. So oxygen looked like that. It could be in colours, it could be with different shading, it could be different shapes. Okay, draw oxygen, water and carbon dioxide using the key provided. So you've already worked out what oxygen, carbon dioxide and water are, and then you just draw them. Obviously, like I've said before, make sure the lone element, so water, the lone element is oxygen. Make sure the oxygen's in the middle. So the lone element is in the middle, and then you've got the elements that you might have more than surrounding. Okay, don't draw them in one line. Separating mixtures. These are the 4 ways to separate mixtures you need to know, and you need to know what they separate. So filtration separates an insoluble solid, so something that will not dissolve in water, from a solution. That's something like sand in water. So a really easy way of separating it is just to put it in a filter funnel with filter paper. You get the water out and you're left with the sand in the filter paper. Evaporation, to separate a soluble solid from solution, so something like sugar dissolved in water. You can then heat it up and you'll get rid of the water. You can then condense it if you want the water back, and you'll end up with just your soluble solid, such as sugar, at the bottom of your beaker. Distillation, separate 2 soluble mixtures. That's normally separated based on their boiling point. That comes up a little bit more in the water topic. Chromatography, separate mixtures of coloured compounds. Each mixture has a different density, so the density depends on how far they move up the filter, the paper you use. It's often filter paper that we use. Back at the top then, ionic compounds, use the common table of ions to help you complete them. This is in the back of your book, and it's also in the exam paper next to the periodic table. So lithium is a plus, fluorine is a negative, so you don't have to do anything. That's LiF. Magnesium is 2 plus, chlorine is a negative, so that'd be MgCl2, because you want to balance it out. You want to have the same number of positives as negatives. If they ask you about ions, positive ions have lost an electron, and negative ions have gained an electron. That's what ions means, and that word is different from atoms, because atoms have not lost or gained an electron. Ions, however, have. How do we work out the relative atomic mass number of a compound? And then there's some examples there. Oxygen is 16, that's the mass number of oxygen. Sodium is 23, and magnesium is 24. Moving on then to work out the relative formula mass. Masses of all the elements in a compound added together. The example I've given is water. So I've got 2 hydrogens, so 1 plus 1, and then I've got 1 oxygen plus 16, which is the mass number of oxygen. Add them all together and that equals 18. Other things you might be asked to do is to write the word or symbol equation for magnesium's reaction with oxygen. So magnesium plus oxygen goes to magnesium oxide. Remember that no atoms are lost. Okay, went in, they just have rearranged to form a new product. So magnesium plus oxygen, remember oxygen is one of the diatomic ones, it exists as a pair, MgO, and then I've balanced it to make sure I've got the same number of magnesiums on both sides and the same number of oxygens on both sides. Another question you may be asked, percentage composition, so how much of hydrogen is in methane. So work out the MR of methane, the mass of methane, work out the mass of the hydrogens, divide them by each other, times by 100. So 25% of methane is hydrogen. Last kind of equation you'll be asked, percentage yield. The factory wanted to make 100 grams of ethane, however they only made 72. What is the percentage yield? So actual yield divided by theoretical yield, so 72 divided by 100 times by 100, that's quite a nice equation there, 72%. Another thing you might be asked is how do you know a chemical reaction has taken place? This also comes up with rates, so they're the kind of things you'd be looking for to prove that a chemical reaction has taken place, or to observe that a chemical reaction has taken place. And then you need to have an awareness of the state symbols. So if something's got an S next to it, it's solid, liquid and gas. And then the one that you might get a little bit confused with is something called aqueous, which essentially means something has been dissolved in a solution, and that solution is normally water.